right, problem number 4. For any date in history, Arthur can quickly tell you what day of the week it was. You choose 3 dates at random, and Arthur tells you the day of the week for each. What is the probability that at least 2 of the dates occurred on the same day of the week? Alright, well, let's first of all think about what probability means. Alright, and in order to calculate the probability, we count the number of desired outcomes. Okay, and in this case, the desired outcome is where we have at least 2 days of the week are the same. Okay, and we divide that by the total number of outcomes. Okay, so that's the total number of ways that we could arrange the days of the week in these 3 dates that we choose. Okay, so so that includes both those that have at least 2 dates the same and those that do not have at least 2 dates the same, or where all the dates are different. Okay, so we take the total number of desired outcomes and divide it by the total number of outcomes. Well, let's start with the denominator here. The total number of outcomes is just equal to, let's see, we have 7 days of the week, so we have 7 choices for the first date that we choose, and we have 7 choices for the second and 7 for the third. So we just get 7 cubed. And I'm actually not going to calculate that out because it's the denominator of this ratio. So I'm hoping that there'll be, I'm thinking there might be some ways to simplify the answer. So some things might cancel. So I'm just going to leave it as 7 times 7 times 7, or 7 cubed. Okay. The trickier part of this problem is to find the number of desired outcomes, the number of ways that you can get at least 2 dates, or 2 days of the week, the same. Alright? And there's a number of different ways you can do this. You could look at it in terms of, so it's at least 2, so, and we've only chosen 3 dates, so it essentially means that it's, the number of ways we can have 2 dates the same or 3 dates the same. So you could do some casework and look at the number of ways that you could have 2 dates the same and the number of ways that you could have 3 dates the same, and add those together. But I'm actually going to do it hopefully an easier way by looking at the complement. Now, this is not the kind of complement you might be familiar with. Alright, notice I'm spelling complement here with an E. Now the kind of complement you might be familiar with is spelled C-O-M-P-L-I-M-E-N-T. Alright, complement, alright, with an I. Now this is some sort of praise, like, boy, you did a really nice job on that, solving that problem, or boy, your hair sure looks nice today. You got a really nice haircut. That would be a compliment. Okay. In this case, complement, this word actually comes from the word complete. So, so the complement of something is something that completes it. All right. So here we have the number of desired outcomes, which is at least 2 dates that are the same. Okay, and the complement of that, the complement with an E, is what is the sort of the opposite of that. So here we have, this would be either 2 dates or 3 dates the same, right? So the complement of that, the opposite of that, would be where we have no dates the same. So we have 3 different dates, or 3 different days of the week, sorry, for the dates that we choose. Okay, so we have 3 different days of the week. And that would complete the, so if we were to add up the number of ways where we had no dates the same, or 2 dates the same, and 3 dates the same, that should add up to the total number of outcomes, right? So it completes the whole, all right? So, all right, so what I want to do is I want to count the complement, because I know that if I count the complement and I subtract that from the total number of outcomes, then I will get what I was looking for, right? So what I want to count is how many ways could all the days be different. Okay. How many ways could all the days be different? Okay, so we'd have Monday, Wednesday, Friday, or we'd have Tuesday, Thursday, Saturday, or we'd have Monday, Tuesday, Sunday, or, so all the days would be different, okay? So let's count that. And so we have, okay, so if all the dates are different, then we would have 7 choices for the first date, 6 choices for the second date, because we can't reuse the date. Once we've used Monday, we can't use Monday again. So now we only have 6 days of the week to choose from. And then we have 5 for the third day of the week. Okay? So, so that's the number of ways that they could all be different. So let's take a look at the probability. This is again the complementary probability. So the probability of having all the days be different, probability of all different days of the week, would be, now we'd have 7 times 6 times 5 over 7 times 7 times 7, right? Because that's the total number of outcomes is 7 times 7 times 7, and the number of ways that we could get all of the days of the week to be different would be 7 times 6 times 5, and you can see that I can cancel out a 7, right? Because 7 over 7 is 1, and I just get 30 over 49. But that's not the probability we're looking for. This is the number of ways that we could get, or the probability that all of the days would be different days of the week. And we want to find out how many ways that we could have at least 2 days of the week the same. And that's just the complement of this. And so if I take this probability and subtract it from 1, so if I take 1 minus 30 over 49, alright, this becomes essentially 49 over 49, and I get 19 out of 49. So that's the probability where of at least 2 of the dates occurring on the same day of the week. Okay, so all we did was we found the complement, because that was a little easier to count, alright, and divided it by the total number of ways, and then we knew that the complement completes the whole, right? So the probability of the number of ways that the days of the week could be different, and the probability that the number of ways, or the number of the probability that at least 2 of the dates would occur on the same day of the week, we know that total probability has to be 1, right? So if we take 1 minus the ways, the 1 minus the probability that the days of the week are all different, then we would get the what's left over, which is the ways that the dates could occur on this or at least two of the dates could occur on the same day of the week. Okay? I don't know if that made sense. I want to show you the other way too. That's the answer, and that's actually the easiest way to do it, is to look at the complement of what we're trying to count. Okay? So, but I could also do it, show you the more straightforward way. Well, I don't know if it's necessarily straightforward, but it's a little harder to count, but it's not that bad. So let's look at case 1, where we have 2 days of the week are the same. Okay, this is the trickier one. So case 1, so we have 3 days. I'm just going to put little blanks here. So we could have the first one and the second one be the same date, or we could have the first one and the last one be the same date, or we could have the last 2 be the same date. Okay? Now, how many different days could we choose for that same date? We'd have 7 choices for this X here. And then this one would be different because we're saying exactly 2 are the same. So this would be 7 times 6. Alright? And again, we have 7 choices for the X, the day that's the same, and times 6 because we'd have 6 choices for this other one. And again, this one would be the same thing, 7 times 6, right? We have 7 choices for the X and 6 choices for the other one. Okay? So this is counting the number of ways that that 2 of the days could be the same. So exactly 2. Maybe I should put that, exactly 2. Exactly 2 days are the same. And case 2 would be where we have 3 days the same. Alright? So that would look like X, X, X. Alright? And then we have 7 days of the week, so that's just 7. And there's no other way to, no other ways to do it. We could either have Monday, 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 Tuesday, Tuesday, Tuesday. So it's just 7 choices. Okay? And if we add those up, we get, well, and here you have to add these up. First of all, because we have essentially 3 different cases within this case 1. So that gives us 7 times 3 times 6, which is 18. So we have 7 times 18 plus 7. So 7 times 18 plus 7 is equal to 7 times 19. Okay? And then if we divide that by 7 times 19 over 7 times 7 times 7, we get the same thing we got up here, which is 19 out of 49. Okay? So that's the other way to do it, by casework. Now that's a little bit trickier to count that way, or there's a lot more work involved. You have to think about all these different cases here and count them all and then add them up. Whereas in this case we only had one way that we could get, or we only had to count up the ways that all the dates could be different, and then we subtracted it from the total number of ways, or total number of ways that the dates could come up. Okay, so you can do it either way, whichever one makes the most sense to you. This one in the long run is quicker because you do get sometimes some problems that doing all this casework is a lot of work. Okay, so it's good to start thinking about the complement, and whenever you see, especially when you see the words at least, so many, you might want to think about the complement of that. All right, so that's the answer, 19 out of 49.